In this video, we're going to talk about taking the integral of polynomials. So I have the integral of 3x squared plus 6x minus 4 dx. Okay, so if you think about it, when we take derivatives, we take the derivative term by term. So I should be able to integrate term by term as long as we're adding and subtracting. So I'm saying because none of these are multiplying, we can go ahead and just integrate this piece, and integrate this piece. Okay, so I'm going to go ahead and just write it right below. So if I integrated this first piece, that 3 is going to hang out, adding a 1, and then divide. So that's the integral of this first piece. All right, the second piece, add a 1 and then divide. The exponent of 1, add 1 more is 2, divide by 2. And then, I don't think I've talked about this rule yet in any of my videos. So if you think about it, what would I have to get a constant as its derivative? And the answer is an x. So what happens is that if you are just integrating a constant, so let me just write this rule. So if I'm just integrating a constant, then my answer is just the constant the constant times x plus c. Okay, because like if this was a 6x, the derivative of 6x is just 6. Okay, so there we go, minus 4x. Now, I would want to put a plus c, but I can clean this up a little bit. 3 over 3 will reduce, 6 over 2 will reduce, minus 4x won't reduce. Let's go ahead, and I'm going to erase my little rule that I just wrote. I'm going to get x cubed plus 3x squared minus 4x plus c. And again, the beautiful thing about finding antiderivatives or integrals is that you can check your work just by taking a derivative. So if I take a derivative of this, I should get back to the original. Okay, polynomials are pretty nice. The tricky part is what if it isn't a polynomial? Can we rewrite it like a polynomial? Okay, so that's going to be my next example right now. So what if I had x to the third minus 5x all over x to the third. Okay, so x to the third minus 5x all over x to the third dx. Okay, if you think about it, if we were finding a derivative, this would scream quotient rule. Well, we're at the beginnings of integration, so we haven't talked about how to undo a quotient rule problem. It's not easy. So what we'd want to do is if we could write it as a polynomial or polynomial-like, we would want to do that. So that's what we're going to do here. We're going to divide each piece by x cubed. Now, I haven't integrated yet. And why did I write a 3? Let's fix that. Okay, so x cubed over x cubed, that is just 1. This would be 5 over x squared. All right, we're getting closer to being able to integrate. Okay, the reason why I say closer is that we could integrate this with our new rule. If you just have a constant, when I integrate this, I'll get the constant times x. But this one I need to rewrite. Instead of having it as x to the second in the denominator, I'd want to write that as x to the negative 2. So it's ready for the power rule. All right, so here we go. I'm going to drop the integral symbol because I'm actually integrating. And when I integrate 1, I get x minus 5x to the negative 2 plus 1 is negative 1. Divide by negative 1. So I'm going to get x plus, because these two negatives will be a plus, 5x to the negative 1 plus c, or x plus 5 over x plus c. So there's 2 ways to write the answer of our original integral. Now, one little problem here is because we rewrote the original integral, if you find the derivative of this, what it's actually going to find is this, not our original up here. Like our answer is not going to look like that algebraically. We could make it look like that algebraically, but if I check this, it'll look like this step. All right, good luck.